In this video, we'll understand the concept of application of trigonometry or heights and distances. Now, this chapter will have word problems based on whatever trigonometry we have done in the previous chapters. Now, let's take the example here. So, for example, if somebody is standing here, a person is standing here and the person is watching something at a height above his eye level. So if I am watching something above my eye level, so I have to look up and watch it. So it is doing the same thing here. So if somebody is watching anything from here to the to this point, that means is looking up, and this angle we call as angle of elevation. So for example, a boy is standing here and he's watching at a mountain or sun or a top of the tree or tower. So all these things come under angle of elevation. In the same way, somebody is, if I have to watch below my eye level or if I have to watch something down, this is called angle of depression. Somebody is here and watching down, this angle is called the angle of depression. Now always remember, the angle of depression is made with the horizontal. Usually kids make a mistake and they make the angle of depression this one, which is wrong. The angle of depression is always between your hypotenuse and the horizontal. Similarly, elevation is with respect to the ground unless mentioned. Now, these are the major concepts of application of trigonometry. Now, how to apply them in the questions. Now, in a question, you'll be given something like, if you'll be given theta, you'll be given the height of the tower, and you'll be said, find the length of the shadow. Now, in that case, we have to go for tan theta because hypotenuse has no role to play here. We will be dealing with perpendicular and the base. So, depending on the question, for example, if somebody is flying a kite, in that case, if the length of the string is given, we are dealing with here hypotenuse. And if it is asked what is the height of the kite, then we go for sine theta because here this part is unknown, this part is known. So this is how, based on what is given to you and what are we supposed to find out, you can use sine, cos or tan here. Now let us take an example to understand this concept better. The length of the shadow of a vertical tower on level ground increases by 10 meters when the altitude of sun changes from 45 degrees to 30 degrees. Now remember, in exam you will not be given the diagram. You are supposed to comprehend the question and draw it on your own. So here the angle when changes from 45 to 30 degrees, the shadow, the length of the shadow changes by 10 meters. A quick trick to understand where to put 30, where to put 45. 90, the closer angle to 90 is what? In between 30 and 45. 45 is more close to 90, so this will be a 45 degrees and this will be a 30 degrees. It's just a trick to identify the angle. Now let's solve it here. In triangle, let's take a triangle ABC first. In triangle ABC, now because we have given the perpendicular and we are supposed to find the base, so we are supposed to be relating the perpendicular and the base, we'll use tan theta here. So tan 45 is equal to AB upon BC. Tan 45 is 1, so this implies 1 is equal to H upon BC. This implies BC is equal to H meters. Now we'll take the other triangle, as triangle ABD. In triangle ABD, tan 30 is equal to AB upon BD. We'll just put the values. This implies tan 30 is 1 upon root 3. So 1 upon root 3 is equal to H upon H plus 10. We'll just cross multiply this. So H plus 10 is equal to h root 3. We take the root 3 on the other side, so it is 10 is equal to h root 3 minus h. I can take h common, so h root 3 minus 1. Now we'll solve further, and h will be equal to 10 upon root 3 minus 1. Now we don't leave the answers in root 3, so what we'll do is we'll multiply and divide by root 3 plus 1. So because we don't keep the irrational denominators, we have to rationalize the denominator, making it 10 into root 3 plus 1 upon a plus b into a minus b. So will be 3 minus 1, which is equal to 2 here. So this is equal to, I can write this as 5 into root 3 plus 1 meters. Now in case you are given the value of root 3, you can just put the value of root 3 as 1.732, and you can just simplify and get your answer as 5 into 2.732, that should be around 13.66 meters. So this is how you can solve more questions based on application of trigonometry or heights and distances.